Hello, in this lecture we'll find out the radius of the circle. In the drawing we have a circle. Inside the circle we have chord AC that is equal to square root of 2 units in its length. Chord DB equals to 2 units. This angle BED, equals to 45 degrees, and our mission is to find out the radius of this circle. In order to find out the radius of this circle, we use two rules. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Here we have peripheral angle ACB that rests on chord AB, and it is equal to alpha. Here we have central angle AOB that rests on the same chord called AB. And because of the fact that the peripheral angle equals to alpha, it means that central angle must be equal to 2 alpha. Okay? So the central angle is twice as big as the peripheral angle that rests on the same chord. Okay? Here the peripheral angle is alpha, the central and it rests on chord AB. The central angle rests on this central angle rests on the same chord called AB, therefore it must be equal to 2 alpha. Okay. The second rule that we use is actually the law of cosines. According to the law of cosines, the law of cosines is true in any triangle, so this triangle ABC could be any triangle. The length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units. This angle BAC equals to theta, then according to the law of cosines, the following equation is true. That C square equals to A square plus B square minus 2 times A times B times cosine theta. Okay? So from this equation, it is very easy to arrive to this equation, that cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2AB. Okay? So, we define the center of this circle. This point is point O. We join together points O and B, points O and D, points O and A, and points O and C by a straight line. Okay. So actually, those 4 line segments OB, OD, OA, and OC are all the radii of the circle. Why? Because of the fact that it starts from point O, that is the center of the circle, and ends at any point on the circle itself. Points B, D, A, and C, they are all on the circle. And this is exactly the definition of a radius. So all those 4 line segments are the radii of this circle. We define the radius of this circle as R, and therefore OB equals to R, OD equals to R, OA equals to R, and finally OC also equals to R. In the next step, we focus on the straight line AB. Okay, at point E, this angle equals to 45 degrees, therefore the missing angle must be equal to 135 degrees, according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So, if we focus at point E on the straight line AB, at the upper side of the straight line AB at point E, here the sum of the angles must be equal to 180 degrees. So 45 degrees plus 145 degrees equals to 180 degrees, exactly according to the rule that I mentioned. Okay. So in the next step we will focus on the green triangle, triangle AED. But before that, we will define peripheral angle ADC as y over 2. This peripheral angle ADC rests on chord AC. Therefore, the central angle AOC that rests on the same chord AC must be equal to twice of y over 2. Y over 2 times 2 is y. So the central angle equals to y degrees in its size. And in the next step we'll focus on the peripheral angle BAD. We define this peripheral angle as x over 2. So this peripheral angle rests on chord DB, and it is equal to x over 2 according to our definition. Therefore, the central angle DOB that rests on the same chord DB must be equal twice of this angle. That is to say, it must be equal to x over 2 times 2 is x. Okay. In the next step, we'll focus on the green triangle, triangle AD. According to the rule that the sum of the angles in any triangle is equal to 180 degrees, we get that the sum of the angles in triangle AD equals to 180 degrees. So, which angles we have inside triangle AD? We have x over 2 plus y over 2 plus 135 degrees. In total, they must be equal to 180 degrees according to the rule that I mentioned. I'll repeat again. X over 2 plus y over 2 plus 155 degrees must be equal to 180 degrees. In triangle AD, the green triangle, triangle AD. So, we subtract from this equation 135 degrees, and we get that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. In the next step, we multiply this equation by 2, and we get that 45 degrees times 2 is 90 degrees. X over 2 times 2 is x, y over 2 times 2 is y, so x plus y equals to 90 degrees. We'll subtract from this equation x, and we'll get that y equals to 90 degrees minus x. Okay, y equals to 90 degrees minus x. In the next step, we will implement the law of cosines on the pink triangle ADB. According to the law of cosines, on the pink triangle DOB, cosine x equals to r squared plus r squared minus 2 squared. 2 squared is 4, so it is minus 4. So it is r squared plus r squared minus 4 over 2 times r times r. So according to equation number 1, we found out that, and according to the law of cosines, in the pink triangle DOB, cosine x equals to r squared plus r squared minus 4 over 2 times r times r. Totally, cosine x equals to r squared plus r squared is 2r squared minus 4 over 2r times r is 2r squared. So according to equation number 1 and the law of cosines, cosine x equals to 2r squared minus 4 over 2r squared. So we'll split this expression into two parts. The first part will be 2r squared over 2r squared, and the second part of this expression will be minus 4 over 2r squared. So we found out actually that cosine x equals to 2r squared over 2r squared is 1, and here we have minus 4 over 2 is minus 2, so we have minus 2 in the numerator. In the denominator we have r squared. So actually, according to equation number 1, we found that cosine x equals to 1 minus 2 over r squared. Okay. In the next step, we will implement the law of cosines on the yellow triangle, triangle ACO. The yellow triangle, triangle ACO. according to the law of cosines, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2. So it is r cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So according to the law of cosines, the yellow triangle ACO, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. In the next step, we'll split this expression into 2 parts. And we get that cosine y equals, the first part will be 2r squared over 2r squared. And the second part is minus 2 over 2r squared. So cosine y equals to 2r squared over 2r squared is 1. And here we have minus 2 over minus 2 is minus 1. So in the numerator we have minus 1 over r squared. So actually, according to equation number 2, we found out that cosine y equals to 1 minus 1 over r squared. So here we have only found that y equals to 90 degrees minus x. So we substitute y in this equation number 2 by 90 degrees minus x. And we get that cosine y equals to cosine y is 90 degrees minus x. And cosine 90 degrees minus x equals to sinus x. Okay. So in conclusion, we found out that cosine y equals to sinus x. Cosine y equals to sinus x. Therefore, we'll substitute cosine y in this equation number 2 by sinus x. And you get that according to equation number 2, cosine y is sinus x. And it is equal to 1 minus 1 over r squared. This is according to equation number 2, and we already found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. In the next step, we will define 1 over r squared as t. That is to say, 1 over r squared equals to t according to our definition. So we substitute 1 over r squared in those both of equations, equation number 1 and equation number 2, by t. And we get that according to equation number 1, cosine x equals to 1 minus 2 times 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t. In conclusion, we found out that according to equation number 1, cosine x equals to 1 minus 2t. We will do the same operation on the second equation. According to the second equation, sinus x equals to 1 minus 1 over r squared. But 1 over r squared equals 2t, so we substitute 1 over r squared by t in this equation, equation number 2. And finally, we found out that sinus x equals to 1 minus t, and cosine x equals to 1 minus 2t. Okay. In the next step, we will use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. Okay. So we'll implement this trigonometric identity in our two expressions. The expression for sinus x and cosine x. So we have here sinus square x. Sinus x equals to 1 minus t, therefore sinus square x equals to 1 minus t squared plus cosine square x equals to 1. So cosine square x, here we have cosine x equals to 1 minus t, therefore cosine square x equals to 1 minus t squared. And it is equal to 1 according to this trigonometric identity. So here we'll open the brackets on this side of equation number 3, and we get that according to equation number 3, 1 minus t squared equals to 1 squared, that is 1 plus t squared minus 2t. We'll open the brackets of this expression also. 1 minus 2t squared equals to 1 squared plus 2t squared, that is 4t squared, minus 2 times 2t, it is minus 4t, equals to 1. So here we have t squared plus 4t squared is 5t squared, and we have minus 2t minus 4t is minus 6t, and we have 1 on both sides of the equation, so 1 will get cancelled, and we are left only with this one, so it is plus 1, that is equal to 0. In the next step, we'll substitute minus 60 by minus 5t minus 1t. And we get that according to equation number 3, 5t squared minus 6t is minus 5t minus t plus 1 equals to 0. In the next step, we will take out a common factor of 5t from those two expressions. So 5t was taken out as a common factor. What is left from 5t squared after we took from it 5t as a common factor? What is left? It is actually t. What is left from minus 5t after we took from it 5t as a common factor? What is left is actually minus 1. In the next step, we'll take out a common factor of minus 1 from those two expressions in the yellow color. So minus 1 is taken out as a common factor. What is left from minus 2 after we took from it minus 1 as a common factor? What is left is actually t. And what is left from 1 after we took from it minus 1 as a common factor? What is left is minus 1. Why? Because and minus is plus. Or minus times minus is plus. So here we get plus 1, exactly like this expression. And it is equal to 0. In the next step, we take out a common factor of t minus 1 from those two expressions. So what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor? What is left is actually 5t. And what is left from minus t minus 1 after we took from it t minus 1 as a common factor? What is left is actually minus 1 equals to 0. So here we have two solutions to the possible for the value of t to solve this equation number 3. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. So if t minus 1 equals to 0, it means that t equals to 1. According to our definition, t equals to 1 over r squared, so we will substitute t in this equation by 1 over r squared, and we get that 1 over r squared equals to 1. We multiply this equation by r squared, and we get that r squared equals to 1. We take a root out of this equation, and we get that r equals to plus minus the square root of 1. The square root of 1 is minus 1. But because of the fact that r is a length and the length cannot be a negative number, we cancel that solution and we left with only the second solution, that r equals to the positive square root of 1. This positive square root of 1 is 1. So in conclusion, we found out that r equals to 1. R equals to 1. We have the second solution that is possible for equation number 3 is 5t minus 1 equals to 0. We will add 1 to this equation and we will get that 5t equals to 1. We will divide this equation by 5 and we will get that t equals to 1/5. T equals to 1/5, but t is equals to 1 over r square, so we'll substitute t by 1 over r square equals to 1/5. We will cross multiply this equation and we will get that r square equals to 5 r square equals to 5. We take a root out of this equation and we get that r equals to plus minus the square root of 5. Okay, but r cannot be equal to the negative square root of 5 because of the fact that r is a length, and a length cannot be a negative number, it must be positive. So we cancel the solution and we left only with the solution that r equals to the positive square root of 5. Okay. So we have here two solutions that are possible for r. Either it is equal to the square root of 5 or to 1. Okay, we'll focus on our problem. Here code dB equals to 2 units according to what is given as the question. It is very easy to see from the drawing that code dB doesn't pass through point O, that is the center of the circle. Okay, therefore chord dB is not the diameter of this circle. Why? Because any chord that doesn't pass, because the diameter of a circle must pass through point O. Therefore chord dB is not the diameter of this circle. And we also know that the diameter of the circle is the longest chord in the circle. So the diameter 2r must be greater than dB. Why? Because it is the longest chord in the circle, and dB is not the diameter. Therefore the diameter dB must be greater than dB. That is not the diameter. So in conclusion, you can write down that the diameter 2r that is the longest chord in the circle must be greater than dB, that is not the diameter of the circle. Okay, 2r is greater than dB. Here dB equals to 2 units according to what is given us in the question, so we will substitute dB by 2 in this inequality, and we will get that 2r is greater than 2. We divide this equation by 2, and we get that r is greater than 1. So r is greater than 1, so the solution that r equals to 1 is not correct, because r must be greater than 1, and therefore we left with the second solution that is possible for r, that is r equals to the positive square root of 5, or in terms of numbers it is equal to 2.236 units. And that is the answer to the question. I repeat again, the radius of this circle r equals to either square root of 5 units, or in terms of numbers it is equal to 2.236 units. In the next step I will summarize the lecture. Okay. this lecture, we found out, our mission is to find out the radius of this circle. Chord DB equals to 2 units in its length, chord AC equals to square root of 2 units in its length, and finally this angle DB equals to 45 degrees. Okay, so first of all, in order to find out the radius of this circle, we used two rules. The first rule is that the central angle is twice as long as the peripheral. The central angle is twice as big as the peripheral angle resting on the same chord. Repeat again the rule that we used. The central angle is twice as big as the peripheral angle resting on the same chord. This angle ACB is the peripheral angle that rests on chord AB, and it is equal to alpha. This angle AOB, is central angle that rests on the same chord AB. Therefore, according to this rule, the peripheral angle that rests on the same chord as angle ACB must be twice as big as the peripheral angle ACB. The peripheral angle ACB equals to alpha, therefore the central angle AOB must be equal to 2 alpha. Okay? So actually, the peripheral angle is twice as big as the peripheral angle that rests on the same chord. That is the rule, the first rule. The second rule is the law of cosines. The law of cosines is true in any triangle. So this triangle ABC could be any triangle. This triangle ABC, side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units. And this angle BAC equals to theta. Then, according to the law of cosines, C square equals to A square plus B square minus 2 times AB times cosine theta. So from this equation, it is very easy to write to this equation that cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay, so in the next step, we defined the center of this circle at this point as O. We joined points O and B, points O and D, points O and A, and points O and C by a straight line. So those 4 line segments, OB, OD, OA, and OC, they are all the radii of this circle. Why? Because they start from the center of the circle and end at points B, D, A, and C that are on the circle itself. And this is exactly the definition of a radius. Okay, so we define the radius of this circle as R. So OB equals to OD equals to OA equals to OC equals to R. They are all the radii of this circle that is R. In the next step, we focused on the straight line AB. In the straight line AB, we have at point E this angle that is equal to 45 degrees. Therefore, the missing angle must be equal to 135 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, the sum of the angles on the upper side of the straight line AB at point E must be equal to 180 degrees. So if this angle is 45 degrees, the second angle must be equal to 135 degrees in order to complete the sum of the angles to 180 degrees. 45 degrees plus 135 degrees is 180 degrees. Then we actually defined peripheral angle CDA is y over 2. Therefore, the central angle AOC must be equal to y, according to the rule that I mentioned. We define the peripheral angle ADB as x over 2. Therefore, the central angle DOB that rests on the same chord must be equal to x. Here, I didn't mention that the peripheral angle ADC rests on AC, and the central angle AOC rests on the same chord AC, therefore it must be equal to y. Okay, so then we implemented the law of cosines in the pink triangle DOB. According to the law of cosines in the pink triangle DAB, cosine x equals to r squared plus r squared minus 2 squared. 2 squared is 4 over 2 times r times r. I repeat again, in the pink triangle DOB, according to the law of cosines, okay, but before that, we have focused on the green triangle AED. Here the sum of the angles must be equal to 180 degrees. So x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. X over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. Then we multiplied this equation by 2 and found out that here x over 2 times 2 is x, y over 2 times 2 is y, and it is 45 times 2 is 90 degrees. So x plus y equals to 90 degrees. We subtracted x from this equation. We found out that y equals to 90 degrees minus x. Then we focused on the pink triangle DOB, and we implemented here the law of cosines. According to the law of cosines, cosine x equals to r squared plus r squared over 2 squared, that is 4, r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. I repeat again, the pink triangle DOB, cosine x equals to r squared plus r squared minus 4 over 2 times r. Then we have, so here cosine x equals to r squared plus r squared is 2r squared minus 4 over 2 times r is 2r squared. So cosine x equals to 2r squared over 2r squared minus 4 over 2r squared. We actually split this expression into two parts. The first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. So cosine x equals to 2r squared over 2r squared is 1. And here minus 4 over 2 is minus 2. So in the numerator we have minus 2, and the denominator we have r squared. So according to equation number 1, cosine x equals to 1 minus 2 r squared. Then implemented the law of cosines in the yellow triangle ACO. According to the law of cosines in the yellow triangle ACO, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is r squared plus r squared minus 2 over 2 times r times r. Repeat again, in the yellow triangle, according to the law of cosines in the yellow triangle ACO, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So cosine y equals to r squared plus r squared is 2r squared minus 2, and 2r times r is 2r squared. We split this expression into two parts. So cosine y equals to, the first part is 2r squared over 2r squared, and the second part is minus 2 over 2r squared. So cosine y equals to 2r squared over 2r squared is 1, and minus 2 over minus 2 is minus 1, so in the numerator we have minus 1, in the denominator we left with only r squared. So according to equation number 2, cosine y equals to 1 minus 1 over r squared. Actually, cosine y equals to, we have the trigonometric identity, we already found out that y equals to 90 degrees minus x, so we substitute y in this equation, equation number 2 by 90 degrees minus x. And then again we substitute y by 90 degrees minus x. So cosine y equals to cosine 90 degrees minus x, and cosine 90 degrees minus x is sinus x. So in conclusion, we found out that cosine y equals to sinus x, therefore we substitute cosine y in this equation, equation number 2 by sinus x. Okay, cosine y equals to sinus x. So cosine y is sinus x, and according to equation number 2, it is equal to 1 minus 1 over r squared. So cosine x equals to 1 minus 1 over r squared according to equation number 2, but according to equation number 1, we found out that cosine x equals to 1 minus 2 over r squared. Then we substitute, we defined 1 over r squared by 1 over r squared equals to t according to our definition, and then we substitute 1 over r squared in those both equations, equation number 1 and equation number 2 by t. So here we have cosine x equals to 1 minus 2t, or cosine x equals to 1 minus 2 times here it is minus 2 times 1 over r squared. Okay, so cosine x equals to 1 minus 2, and 1 over r squared is t. Therefore, this expression will be equal to minus 2t. So, actually we found out that in total, according to equation number 1, cosine x equals to 1 minus 2t. Then, according to equation number 1, sinus x equals to 1 minus 1 over r squared. 1 over r squared equals to t. Therefore, sinus x equals to 1 minus t. So according to equation number 2, sinus x equals to 1 minus t. Then we have the trigonometric identity that sinus square x plus cosine square x equals to 1. So we have the expressions for sinus x and cosine x. If sinus x equals to 1 minus t, then sinus square x equals to 1 minus t squared. And if cosine x equals to 1 minus t, then cosine square x equals to 1 minus 2t squared. And according to this trigonometric identity, it will be equal to 1. We open the brackets on this side of equation number 3 and found out that according to equation number 3, 1 minus 2 squared minus 1 minus t squared equals to 1 squared plus t squared minus 2t plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, and it is equal to 1. So t squared plus 4t squared is 5t squared. Here we have 1 on both sides of the equation, so 1 will get cancelled and we're left only with this one. So in conclusion, we found out that according to equation number 3, 5t squared minus 6t plus 1 equals to 0. Then we substitute minus 6t by minus 5t minus t. Okay, and we found out that according to equation number 3, 5t squared minus 6t is minus 5t minus t plus 1 equals to 0. Then we took out 5t as a common factor from those two expressions, so inside the brackets we left with t minus 1. Then we took out minus 1 as a common factor from this expression in the yellow color, so inside the brackets we left only with t minus 1, and it is equal to 0. So then we took out t minus 1 as a common factor from those two expressions. So t minus 1 is taken out as a common factor. So inside the brackets we left with 5t minus 1, and it is equal to 0. So here we have two solutions that are possible for the value of t. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. So here, if t minus 1 equals to 0, it means that t equals to 1. Then t equals to 1 over r squared, according to our definition. Therefore we substitute t in this equation by 1 over r squared. Therefore 1 over r squared equals to 1. We multiplied this equation by r squared and we found out that r squared equals to 1. We took out of this equation, we found out that r equals to plus minus the square root of 1. The negative square root of 1 is minus 1, but it is not possible as the answer to this question because r is a length and the length must be a positive number. So we cancel the solution and we left with only the second solution, that r equals to plus 1 unit. Okay, then focused on the second solution that are possible for this equation, equation number 3. 5t minus 1 equals to 0. We added 1 to this equation and we got that 5t equals to 1. Then we divided this equation by 5 and we got that t equals to 1/5. Again, according to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared. So 1 over r squared equals to 5. So we multiply this equation and we found out that r squared equals to 5. Then we took out of this equation and we found out that r equals to plus minus the square root of 5. But the solution, the negative solution, that is the negative square root of 5, is not correct because r must be a positive number. Because it's a length. And it must be a positive number. So we cancel the negative solution and we left only with the positive solution, that r equals to the positive square root of 5. So in conclusion, we have here two solutions r for the radius of the circle. Either r equals to 1 or r equals to the square root of 5. Okay, and here we have the drawing. We have chord dB that is equal to 2 units. It's very easy to see that chord dB doesn't pass through point O, that is the center of this circle. Therefore, chord dB is absolutely not the radius of this circle. Why? Because it is not the diameter of this circle. Why? Because any diameter of a circle must pass through the center of the circle. And therefore, dB is not the diameter of the circle. But we also know that the diameter of any circle is the longest chord in the circle. So the diameter 2r is the longest chord in this circle, and therefore the diameter 2r must be greater than dB, that is not the diameter. Okay, I repeat again here. The diameter 2r must be greater than dB. That is not the diameter of the circle. It is given us in the question that dB equals to 2, so we substitute dB by 2 in this inequality. and we got that 2r is greater than 2. We divided this equation by 2 and found out that r is greater than 1 units. R is greater than 1. So the solution that r equals to 1 is not correct because r must be greater than 1. So we left only with the second solution that r equals to square root of 5. In terms of numbers, it is equal to 2.236 units. Repeat again. The radius of this circle r equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay, thank you very much.